7, 8, and 9, pretty much like we did before, only now we have a little bit more tricky things in order to figure out. So here we have 10 pi over 3. When we figure out our angle, we want it to be pi over 6. So 10 pi over 3 is the same thing as 20 pi over 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's going to make this a 60-degree angle, that one the 30-degree angle. So 1, 2, square root of 3. This is going to be negative, this is going to be negative. My cotangent. On my cotangent, I'm going to have the adjacent over the opposite. So my adjacent is -1. My opposite is negative square root of 3. Since I have a negative over a negative, it's going to be 1 over the square root of 3. And if I rationalize my denominator, I'm going to get the square root of 3 over 3. On my secant, again, this is a -1, so I'm going backwards around. So if I take 360 and subtract 225, I get 135. So 135 would be over here. That's leaving me a 45-degree angle. So I would have 1, 1, and the square root of 2. This side's going back, so it's actually a -1. Secant, inverse of cosine, would be the hypotenuse over the adjacent. My hypotenuse is the square root of 2. My adjacent is -1. So square root of 2 over -1 would be negative square root of 2 for my answer. Now you might have wanted to, on this top one here, figured out what it was equal to by subtracting 2 pi from it until you got something between 0 and 2 pi, and then you wouldn't have to count around so many times. So just for fun, if I have 2 pi and I subtract, actually I want to go the other way around since 10 pi over 3 is bigger. I want to take 10 pi over 3 and subtract 2 pi. 2 pi, if I take that times 3, 10 pi over 3 minus 6 pi over 3 would give me 4 pi over 3. Then if I make that, I would into an equivalent fraction. 4 pi over 3, if I make it over 6, would be 8 pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6, 7, 8. You can see I ended up in the same spot, but didn't have to count around 20 pi over 6 by making and simplifying my value. Since I know I went around once, I could take off the 2 pi, leaving me 4 pi over 3. Number 8, so I'm going to do the cosine of 570. Again, that's bigger than once around, so I'm going to subtract my 360 from it. 210. So 210 would be in quadrant 3. If I take 210 minus my 180, since 180 would be right to the line, that's not what I want to do. 210, 30. So this would be my 30-degree angle. So over here would be my 60-degree angle. So 1, 2, square root of 3, that would be negative, that would be negative. So cosine, for my cosine, I have the adjacent over the hypotenuse. The adjacent is negative square root of 3. The hypotenuse is 2. So I just get negative square root of 3 over 2. Here we're doing a negative 2 pi over 3. Again, I want to make it over 6, so I want to go negative 4 pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. That makes this the 60, and this one the 30. So this would be 1, 2, square root of 3. Of course, that's negative and that's negative since this is going backwards and this one's going down. Tangent. Tangent is opposite over the adjacent. So the opposite is negative square root of 3. The adjacent is negative 1. Since I have a negative over a negative, it's going to make that a positive square root of 3. Number 9, we have negative 180, which means if I take 360 and subtract 180, it's the same thing as a positive 180, right? Negative 180 and positive 180, whether I go this way around or this way around, I end up on the same spot. And when you end up right on the line, it's kind of a unique situation. What you're saying here is that this value here is going to be 1, but it's going backwards, so it's going to be a negative 1. You're going up 0, so this value here is going to be 0, and your radius is going to be 1, because if you use your Pythagorean theorem, a squared plus b squared has to equal c squared. So this is what my triangle is going to look like, but since it's right on the line, I really don't have a triangle, but I'm going to draw it because that's going to be a 0 in there. I want to do the cosecant. The cosecant's opposite the sine, so hypotenuse over opposite. My hypotenuse is 1, my opposite is 0. 1 over 0 is undefined, and that's why they had that choice that says if it's undefined, click on undefined. The next one, we're doing negative 5 pi over 6. It is over 6, so 1, 2, 3's right on the line, 4, 5. That means that's the 30-degree angle. So 1, 2, square root of 3, that's negative and that's negative since I'm in quadrant 3. Secant, opposite of the cosine, so hypotenuse over adjacent. My hypotenuse is 2 over my adjacent, negative square root of 3. I've got to rationalize my denominator, so I'm going to get negative 2 square root of 3 over 3 for my answer. So just keep in mind here, when it is right on the line, depending if it's the x or the y, if it's going up or down, then your opposite one's going to be 1 or negative 1, but your hypotenuse is always going to be 1. So you have two sides that are 1 and one side that's a 0, and could be negative depending on which direction it's going to. By the way, on some of these you could use your calculator. I haven't mentioned that before. But sine, cosine, and tangent, if I have the degree measure, I could use my calculator. If I put in cosine of 570, oh, it doesn't give me a very nice answer because I had this square root of 3 over 2, or negative square root of 3 over 2. My calculator, I get negative 0.866. But if I put in negative square root of 3 divided by 2, I get that negative 8.66. Same equivalent answer. So a calculator doesn't work very well since I want exact, unless it would happen to come out to something really nice, like 1 or 2 or negative 1.